All right, last concept, please. Measurement. Last concept, please. Measurement. Definition. Measurement definition. Measurement is a system of determining the numerical value, that's the magnitude of certain parameters. That's it. In your test, you'll be given measurement for length, for mass, for whatever. Let's look at each of them one by one. Number one, let's look at measurement of length. Measurement of length. Measurement of length. The first thing for this is meter rule. The first one there. Meter rule. Is it TER or TRE? Huh? Meter rule. TRE or TR? Right, TRE, not TR. TRE is British spelling of meter. TER, METER is American spelling of meter. Obviously, we were colonized by the British. So hence, the correct spelling of meter is METRE. Same thing with center. Center is correctly spelled this. Century, right? Century. But that's center, not TR. Whatever. All right. Number one, please. Meter rule. A meter rule measures length. A meter rule measures length upon an accuracy of 1 millimeter. Please cram this thing on the board. Upon an accuracy of 1 millimeter. Please, very important, please. To ask this question, they say find the measuring accuracy of a meter rule. The answer is 1 millimeter, please. Upon an accuracy of 1 millimeter, comma, 1 millimeter being the smallest graduation. One millimeter being the smallest graduation on a meter rule. On a meter rule. Full stop. This gives the reading accuracy of the rule. This gives the reading accuracy of the rule. That's the meter rule. One thing you should expect in your physics practical is diagrams. They give you diagrams for vernier caliper, diagrams for micrometer screw gauge, diagrams for meter rule. They say you should read off the markings. Read off the markings. Let's start with this one, please. How do you read off markings for meter rule? Look up. It's as easy as AB is equal to the distance from B minus distance from A. Look at this. The graduation is 1, 2, 3, 4, whatever. My B coincides with 9, so becomes 9 minus, what's A here? 4.5. What's your value here? 4.5 millimeters. That's it, please. So just the last part minus the first part, that's all. All right, let's look at the next one there, please. Vernier caliper. So please catch this. Let's look at the next one, please. Vernier caliper. So meter is simple. Just the last one where it coincides minus the first one where it coincides. That's literally everything there. Okay. Sorry? Yes. What's what? It is like a pointer. They're saying something like, if I start from here, I measure here, what will be the distance? That's what they're saying. But the man cannot start moving around the hall. So this is like the indication from if I start from here and here. So it's like a statement. Yes. Millimeters, please. Yes. No, everything here is in millimeters. So it's not as if this is centimeter. It's not as if here is millimeter, here is centimeter. No. The same scale throughout. So it's millimeters throughout, please. I would elaborate on this one as we proceed, but note that it's millimeters. You cannot be having millimeters and centimeter on the same place. No, you cannot. B, please. Vernier caliper. A vernier caliper gives a more accurate. A vernier caliper gives a more accurate determination of length. A vernier caliper gives a more accurate determination of length than the meter rule. A more accurate determination of length than the meter rule. Their reading accuracy is about 0.1 millimeters. It's about 0.1 millimeters. For meter rule, 1 millimeter. For vernier caliper, 0.1 millimeter. Full stop. It has a main scale and a vernier scale. It has a main scale and a vernier scale. All right, look up. Vernier caliper has this man here. Look up and listen carefully so you don't mess it up. This man here, meter rule, is in millimeter, 1 millimeter. This man here, vernier caliper, is in 0.1 millimeter. Please convert this to cm. What will it be? Huh? It's 0.01 in cm. Listen. Most likely in your exam, the vernier caliper will be calibrated in cm, not meters. Listen Listen carefully. Most likely in your exam, this one here, they would expect you answer in cm, not millimeters. Listen, how do you easily read off a vernier caliper? The vernier caliper reading, we said vernier caliper has two scales, the main scale and the vernier scale. By the way, that's a past question. The two scales of a vernier caliper are dash and dash scale. The answer is main scale and vernier scale. Here's your main scale, here's your vernier scale. How do you read off a meter rule? Very simple. The N1 minus the initial one, that's all. How do you read off a vernier caliper? You don't use the idea of meter rule for vernier caliper. You don't say end minus initial, no. For vernier caliper, it's always equal to the value you have in your first one here. This one coincides with where? So this is equal to 0.00 cm. Please take note. That's it, that's all. For vernier caliper, I'm only taking this side here, not the two sides. So where this one coincides is what I take, that's all. It becomes 0.00 cm. So just here, express it in 2 dp for your cm. So 0.00 cm. Now hang on. Let me give other examples. Hang on. Better still, let me show you how you see this in your exam, please. Better still, this is how you see this in your exam. Let's take this one as number 1. Want to ask a question? What's the question? Which one? Which of this one here? This one here? This one here? Is it for this one here? I said this is the main scale. This is the vernier scale. I said for meter rule, I'm always taking this value minus this value. And I said for vernier scale, do not bother about this one. Just check where this coincides. That's all. That's what I said. All right. This one here is just a vernier scale. Yes. Yes, anywhere, doesn't matter. The only thing you focus on is just where does this intercept. That's all. Example 2. Better still, this one here now. I'm coming. Listen. In your exam, there are 2 ways to set this question in your exam. The first way is that they'll give you the diagram and ask you to get out the reading. By get out the reading, I mean they'll give you this one here and ask you what's the reading, 0.00. They'll give you this and ask you what's the reading. You produce it. This is case 1. Case 2, they'll give you the reading and ask you to sketch the vernier caliper. So you can say a vernier caliper reads 7.25 cm. Sketch the vernier caliper. That's it. We'll look at both of them. Now listen. It's not hard. For vernier caliper, look for where 0 is intersecting the main scale. That's all. If I look at this, leave this one, doesn't matter. This 0 is intersecting at where? Check. Where? 3, 4, 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.94. 0 is intersecting at 3.2. So this is equal to what there? 3.2. I said it should be in 2 decimal places. 20 in what there? cm. Very simple. Very simple. So your focus should only be where does 0 intersect. That's all. Now look up again. Let me show you something. Look up again, please. Observe the way I'm drawing the main scale from the vernier scale. They're not the same drawing. In the main scale, I'm only focusing on, look at this, 3. This one becomes 1, 2, so 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 to 4. Vernier scale is 0, 1, 2, 3, 4, 5. It's more like saying vernier scale is only calibrated in what there? Zeros, 5s, 10s. You can see. So 0, 1, 2, 3, 4, 5. 5 is the major one there. 6, 7, 8, 9, 10 is a major one there. Why for this one here is a bit different. It's 3, 3.14, like that. So get a difference, please. What does it take to draw a vernier scale? Very simple. Number one is straight line. Start with a straight line first. Always a straight line. So straight line. Start your calibration. Let's call this 12. 12.1, 12.2, 12.3, 12.4, 12.5, 12.6, 12.7, 12.8, 12.9. Here becomes 13. 13.1, 13.2, 13.3, 13.4, whatever. You can complete there. I have 0 here. It should be 1, 2, 3, 4, 5. It's a major. Okay? 6, 7, 8, 9, 10 is a major. Please look at this, please. Try to read up this scale, please. What is it to be? Huh? 12, 12.1, 0.2, 0.3, 0.4. This is between 12.4 and 12.5. So because what there? 12.45 units. It is that simple, please. It is that simple, please. That's how you read off vernier scale. So 12.45 cm, please. All right, please pause. Please pause. Look at number 3 and 4. Number 3, what do you think is your scale? Huh? 14 points? Okay, so go back 16, 15.9, 15.8, 7.6, 0.5, 0.4, 0.3, 15.2, 15.1, and then 15, and then 14.9. What do you think this will be? Here cannot be 9. This is 14.9. Where will these points be? 14 points? 99. Becomes 14.99 cm. It's always up to your own, look up. It's always up to your own debate. If you write 14.8, they can still give it correctly. Because there's no, but the idea is this cannot be 14.5. That's the idea. This cannot be 14.5 because it has passed the middle. So perhaps something like 14.8, 14.9 would be good enough. That's the idea. Look at this, please. What's the scale here? Check well. What's the scale? 0 points. This is 0. This is 1. Here becomes what there? 0.9. Here becomes what there? 0.8. Let's say this is between here and here. So it becomes what? 0.85. 0.85 in here. Please draw this one for me. Draw a vernier caliper of reading 52.17 cm. Draw the one of 103.45 cm. Please get this to done now, please. Draw a vernier caliper that has. So let's look at let's try to get this to, please. 52.17. Number 5. 52.17. If I were you, cm, of course, if I were you, I would focus more on the value than any other thing first. So that means my major focus is 52 first. So I'll have this one here. I'll have this as 52, 52.1, 2, 3, 4, 5, 6, 7, 8, 9. Here, 53, and then 1, 2, whatever. My zero should coincide with 52.17. In fact, I should have made this in bigger. But then, if I keep this thing at the center here, this is 52.15. For 17, it will shift a bit further to the right. This is 52.15. 17 should be somewhere here. So come here, put here as what there? Hold on. Put here as what? 0, 1, 2, 3, 4 here. 5, 1, 2, 3, 4 here. 10. That's all. That's all. 103.45. Number 6. 103.45 cm. Of course, my first start, draw a line. My major thing here is 103. So here, 103. So I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 104. 0.1, 0.2, and whatever. 987. 103.4. So 103.1, 0.2, 0.3, 0.4. 0.45 will be at the center of 4 and 5. So center of 4 and 5 becomes here. I'll come down here, put 0. I'll have 1, 2, 3, 4, 5. So I have 5 here. 6, 7. All right. So this is 103.45 cm. All right. So that's how we get to this. Hope you got it correctly. Yes. All right. All right. One last one, please. Let's look at micrometer screw gauge, and we are done, please. Let's look at the next one, please. Micrometer screw gauge, please. Take that, please. Measures smaller length. Measures smaller length. Example, diameter of a wire. Measures smaller length. Example, diameter of a wire. Diameter of a wire. Than the vernier caliper. Than the vernier caliper. Than the vernier caliper. And therefore has a higher reading accuracy than the vernier caliper. Therefore has a higher reading accuracy than the vernier caliper, which is equal to 0.01 millimeter or 0.001 cm. It's on the board. Measuring accuracy for meter rule is 1 millimeter. For vernier caliper is 0.1 millimeter. For micrometer screw gauge is 0.01 millimeter. Of the three, the one with the highest reading accuracy is what there? Micrometer screw gauge. It has the highest reading accuracy. All right, let's see how to read a micrometer screw gauge. Reading a micrometer screw gauge. Reading a micrometer screw gauge. You can just notice there, the micrometer screw gauge has two types of scale, the main scale and the thimble scale. Main scale and thimble. Thimble, thimble scale. Vernier caliper has two, main and vernier scale. Micrometer screw gauge is main and thimble scale. All right, all right. So we have these two micrometer screw gauge. Let's see how we read them. Look up, please. Let's see how we read these micrometer screw gauge, please. This is how it should be originally. This is how it should be originally, as per your calibration. More like 0, 1, 2, 3, 4, 5. So observe that there's a bit of a difference between these two, but then it's the same idea. The idea is this, that for every one is a 1. For every marking is a 1. This scale here does not really count at this your level. Observe that I didn't bother to put figures here because it doesn't really count. Focus more on the one up here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. In this one, I made 0, 5, 10 as the major, as it should be. But in your exam, you see it in this way. But of course, the same thing, 7, 8. So each of the markings is 1. How do you read this? Very simple. This is the main scale. I said there's a main and a thimble scale. So this is your main scale. Main scale. This now becomes the thimble scale. First things first, read off the value in the main scale, which as you can see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Observe carefully that the thimble scale here cuts on 11. So your first focus when it comes to reading a micrometer screw gauge is where this thing cuts. This cuts at 11. So it becomes 11.0. Sorry. Becomes 11.00. First up, please. 11.00. So express this in 2dp. Plus, next up, look at where this one coincides with this line. Look at where this one coincides with this line. This is what here? So it becomes 0 point, this value here, 0, 0. Please. This is here, 10, 11, 11.00 in 2dp, please. Plus this one here. This one cuts this point here. That's It's actually 0 points, the figure you see here. So it's 0 points. This figure now appears here in 2dp. If I add this gives you what there? 11.00. Please, this one here is in millimeters, please. It's in millimeters. Now, hang on. This idea, let's try this one here. 6, 7, 8, 9, 10, 11. This one cuts here, perhaps, look at this, it is half of 11 and 12. Here is half of 11 and 12. So this one becomes what there? That becomes 11 point. 11 point what? 50, not 5. I said in 2dp. 11.50 plus this one, I said is always 0 point, the number. So it becomes 0 point. What do you have here? 35. Please add this up. What do you get there? All right. So that's how it's done. That's how it's done, please. That's how it's done. So 11.35. This is 0.35. This is 11.50. And that's it. No, please. No, leave it at millimeter, please. What's the under? The micrometer has two scales actually, right? This one is still a reading though, but it's not your level kind of reading. It's not your level kind of reading. So just leave out this part here. I think this part is more of like a 5. I think so. Here's more like a 5. So more of like 6, 6.5, 7, 7.5, 8, 8.5, 9. I think here is more like a 0.5 reading. I think so, yeah. So that's it. 50. Okay. So let's get this thing done. Let me point your focus to something, please. Check our very first micrometer screw gauge. This was 0. I had 0, 5, and 45. Check. So the maximum there is 45. Don't go and draw something more than 45 here. So there should be no 50 here. So you had 0, 5, 45. Your maximum there should be 45. Bring down to your notice. Let's try to get this man, please. What do you have here? This should be equal to 19, 20, 21, 22, 23, 24, 24.5. This side coincides at where? 25. In 2dp, because what there? 25.00. Plus, this one coincide at, I said this point is always 0 point the number. So it becomes 0 point, what do you have here? 1.5. Please combine this, what do you have here? Units. Is it okay now? It's just simple. Look at this, please. What do you think this is? Huh? This is 17, 17.5, 18, 18.5. That's equal to 18 point in 2dp 50 plus, what's this part? Someone says 0. Someone says 0. Check now. Read your Timbo scale. 25, 26, 27, 28, 29, 30. 26, 27. This is 28. 0.28. So combine this. What do you have here? All right. Any questions, please? I think that one is settled. All right. I'll give you values. See if you can draw the micrometer screw gauge. It's a two-way thing. I'll give you values. See if you can draw the micrometer screw gauge, please. All right. So your task here is now to draw the micrometer screw gauge for each of these. I'll give you a very simple idea on what to do. But first things first, I want to believe number 1 is very simple. Very simple. So 13. So you should expect something like this. So let me call here 13, like this. Here is 12. Here is 11. Here is 10. Here is 9. 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13. And here should be what now? 0, 0, 1, 2, 3, 4. Here was what? 45. 1, 2, 3, 4 here was 5. I said this should not be more than 45. You having 72 here. I don't know if you don't have created your own micrometer screw gauge. So here is simply 13.00, that's 13, plus 0.00, that's equal to 13.00 millimeters. First one, check. Second one, 14.45. Look up, please. 14.45. My first task will always be, can I subtract 5 from this? Is it possible? If yes, subtract. If no, go ahead. For instance, look at this, please. I have 0.5 here, for instance. All right. If I subtract 0.5 here, it will not readily go. I'll have like 13 points and whatever. More like 5 cannot readily subtract this one here. So what do I do here? This one here, I think I'll advise that your first task would be, how do you break it down to 2 components before you start plotting? This one here should be 14.00 plus what there? 0.45. These two are within the limit. My highest was 0.45. So it's within the limits there. Okay, so here becomes 45 to give me 0.45. I'm now having 44, 43, 42, 41. Then this 5, 4, 3, 2, 1. Okay, I'm having this. Okay. 1, 2, 3, 4, this. All right. 0.45 and then 14. So here should be 14, obviously. 14.0 should be here. 14, 13, 12, 11, 10. So I'll call here 13, 12, 11, 10. 10.5, 11.5, 12.5, 13.5, this. So you have this one here. You have this one here. All right. So this now gives you 14.00, of course, plus 0.45. That's equal to 14.45 millimeters. That's for this one. Here should be 44. All right. Okay. 45, 46, 47, 48, 49, 50. Okay. For this one here, look up, please. 45, 46. Yes. So 45, look up, please. 0, 5, this. 0 and 50 coincides here. It's like 45, 46, 47, 48, 49, 50 and 0 coincides here. So here is 50 and 0. It coincides here. So I'm having this, then from here should be 50, 45, 44, 43, 50, 59, 58, 57, right? Sorry, 50, 49, 48, 47, 46, 45, 44. So it should come down there. It's not like saying the maximum there, 45, this 0 is both 50 and 0. So it coincides there. So 45, what comes there is 44, 43, and all of those. But don't worry about that. Get your 45. And that's it. For number 3, 12.72. How do you readily break down 12.72? What plus what will give you 12.72? Huh? Hold on. Number 3, 27.72. Someone was giving me 27 and then 72. That's not possible. It's not. So what do you get here? 27.50 plus what again there? 0.22. That's it. So you can't be having the 72. No. And that's why I said, first thing you do is check here. Listen. What you do is this, check here. If this one is greater than 5, then break it down. So this one will be like your key man there. Observe, this one was not greater than 5. So I use the whole number instead. For the fact that this one can be broken down to 5, I'll now use 27.5 first before this one. Same thing here. I'll use what here? 0. What? 4, Abi? 0, 4, 2 plus what there? 0.50, your maximum. There. Yeah, that's it. That's it. But hold on, no. Hold on. I'll come to this. I'll come to this. Hold on. I'll come to this. All right. Let's get this done, please. 27.50. 27. Here. 26. Here. 25. Here. 24. 24.5, 25, 25.5, 26, 26.5, 27, 27.5 will now be here. So it will now be this. That's 27.5 plus 0.22. So this is 0.22, 0.23, 22, 23, 24, 25. So this is 22. 1, 2, 3, 1, 2, 3, 4. Okay. So I have this. So it becomes this one here. 27 point this 50 plus 0 point this one here 22. So that gives you 27.72 millimeters, please. That's what's safer. All right. Very last one, please. Please, for 0.95, what do you to bring my 2 addition? What will it be? 0 point plus 50 plus. All right, so you get it now. So please don't start using negative. Some of you are using negative here. So obviously 0.5. How do I sketch 0.50? How do I sketch? This is equal to 0.50 plus 0.42. How do I sketch 0.50? Obviously, this is 0. This one here is 0.5. You have to start putting -1. It's not necessary. Just stop here. So 0 and then this. This should actually be at the very end of the scale. So this one here, what I'm having here, then 0.42 here, 42. 42, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's all. This here, 0.5, this plus 0.42. That will give you 0.92 millimeters. Don't worry about it. The more you see examples and you practice it, the more you'd get it. All right, so that's about it. We're done with length. We've talked about length. Let's look at mass. Measurement of mass. Mass is the total quantity of matter contained in a body or an object. That's the definition. Total quantity of matter contained in a body or an object. That's mass. So looking at the measurement of mass, you can say mass is measured using number 1, a lever balance. Number 2, a beam balance. So these are your instruments for measuring mass. Weight is measured using, let me call this A and B. Weight is measured using what's called a spring balance. So spring balance for weight, lever and beam balance for mass. Weight is simply as a result of the force of gravity acting on the mass of a body. Weight is the result of the force of gravity acting on the mass of a body. And that's why weight is equal to mass times gravity. Number 4, measurement of time. What is the measure time? Huh? It's not wall clock, oh. People go and write wall clock. Use a stopwatch. So time is stopwatch. Finally, measurement of temperature. What do you use? All right. Thermometer. Thermometer. All right. So that's it basically. That's it. Basically. Some few more things to note, and there we go. Some few more things to note, and there we go now. Let's look at measuring accuracy of some measuring instruments. Measuring accuracy. Number 1, I'll look at. We've already treated the instrument already, but let me just pinpoint the measuring accuracy. Then we'll go on break, please. All right, number 1, meter rule. Meter rule. I said TRE. Meter rule. Your measuring accuracy for meter rule is 1 millimeter, which is equal to 0.1 centimeter, which is equal to 0.001 meter. Please note all these values. They usually give this. Say find the measuring accuracy of this. They can ask you in either millimeter or centimeters or meters. Know all of them. This one, divide by 10, divide by 1000. That's all. Number 2, vernier caliper. Vernier caliper, measuring instrument, 0.1 millimeter, as we said, in centimeters, divide by 10, 0.01 centimeters. For meters, divide by 1000, 0.0001 meters. What's that? The what? All right, so we said for vernier caliper, I'm having 0.001 meters. Finally, I have micrometer screw gauge. For micrometer screw gauge, your measuring accuracy is 0.01 in millimeters. Divide by 100 gives you 0.001 cm. By 1000 it gives you 0.12341 meters. So please note these men, please. You can be asked any of them, please. Note these men. These are their various measuring accuracy. Also note, I said it like a page. We're almost done. Just 3 things, we are gone. Also note, please. Note number 1. Also note number 1, sensitivity Also note, please, number one, sensitivity is the smallest absolute amount of change. Sensitivity is the smallest absolute amount of change that can be detected by measurement. Sensitivity is the smallest absolute amount of change that can be detected by a measurement. It is often expressed in terms of milli. It is often expressed in terms of milli, micro, or tenths of a degree. Just note that, please. Number two, I said just three things. Number two, just short notes. These are past questions answer actually. Let me just give you now. So I won't come to past question, just solve straight and go, not going back and forth again. Number two, the effect of air resistance in a simple pendulum. The effect of air resistance in a simple pendulum experiment. In a simple pendulum experiment, the effect of air resistance in a simple pendulum experiment can be reduced by tilting. Tilting on the board can be reduced by tilting the pendulum bob at a small angle. By tilting the pendulum bob at a small angle. At a small angle. That is, the angle of swing is small. That is, the angle of swing is small. That is, the angle of swing is small. Finally, number three, before we go. This is one of the regular questions. They always ask you, why is that during, if you actually did the simple pendulum experiment, one of the instruction that they'll give is that you tilt it at what? A small angle. Right? Yes. The instructor in the lab will say tilt at a small angle. Why small angle? The idea is to caution the effect of air resistance. Now, here's what you observe. If I have my simple pendulum and I tilt it at a small angle, it will just go 1, 2, 3, 4, 5, 6. It moves faster. But if it tilts at a bigger angle, at a large angle, push it with too much force, it now go 1, 2, 3 with that big angle. What is happening there now? Air resistance is dragging it. It's going now slower and slower. That's at a large angle. And that's why we use what there? A small angle. Please note this one, please. Finding number three, please. From the equation of a simple harmonic motion, from the equation of a simple harmonic motion, T is equal to 2 pi root h squared plus k squared all over 2gh. All over gh. After transforming to linear form, this is another past question too. After transforming to linear form, K represents the radius of gyration. Radius of gyration of the bar on the board, please. K represents the radius of gyration of the bar pendulum radius of gyration of the bar pendulum and G represents acceleration due to gravity. And G represents acceleration due to gravity. All right. So I think we're good. We'll take a break, come back, and do graph.